now consider the task of text classification in NLP, which is a very important task. Learning to classify text is important because we want, for example, to learn the news articles that are of interest, or learn to classify web pages by topic, or learn to classify spams from non-spams, or to detect the sentiment of a review, or also to detect the language of some text. So naive Bayes classifiers have actually been very successfully applied to text classification. But we can wonder what kind of attributes we should use for naive Bayes classifiers when we have data that is text. We could use, of course, the n-gram model, either unigrams, bigrams, etc. Let's recall first the setting of a naive Bayes classifier. So we have a training data, just like in machine learning. We have xi, yi, which are the set of features and their labels. In the case of the document classification, we have a set of text along with the class, for example, spam, non-spam. A new example is then has a feature values A1, A2, AD, and we want to be able to classify this new example by using the generative model that actually says that y new would be the argument max of p of y given A1, A2, AD. In other words, we're going to pick the label y that actually will maximize this quantity, which is the probability of the label y given the set of features or the set of words in the data. Naive Bayes classifiers use the simplifying assumption that the probability of A1, A2, AD given the label y is the product of the probability over all the features feature values A1, AD. And the reason is that, recall that we actually, there are small chances that we see the occurrence of A1, A2, AD values appearing enough time in the data set to be able to estimate this kind of probability. Okay, so now the y new would be the argmax over the possible labels of what? Of p of y, product of aj y, given y. So this actually applies the simplifying assumption so as we could estimate the label of this new instance. So the algorithm is quite simple. We are going to base our estimation of probability on the frequency or the counts in the data set. We're going to estimate all p of y's for all y's in the set of labels. So it could be y, spam, non-spam. We are going to estimate all p of aj, value aj given y, for all y in the set of possible labels, and all possible labels for or possible words in the document. For a new example, we are going to use just the formula we just saw, which is giving us that the label is the argmax, the function that the label that maximizes the function p of y, product of p of aj given y. Okay, so in naive Bayes, again, there is no model, there is no hyperplane. Just count the frequencies to estimate the probability on various combinations of feature value data with the training examples. So that for estimating the probability, we're going to use the M estimate of the probability to account for the case when the account is actually 0. So we're going to use P of aj given y estimated to total number of examples for which the class is y and the feature value is aj, plus m times p divided by ny, which is total number of examples for which the class is y. We're going to add m times p and divide by m, where m is called the equivalent sample size, in which case we're going to have some kind of extra virtual examples distributed according to some prior p. We're going to add this value to avoid actually having 0, which will actually, if we have 0, it's going to be actually putting the whole product of the probabilities to 0. Okay, so for text classification specifically, we have a corpus. It's a document. We define an attribute for each word position in the document. So it means that we are going to consider the main vocabulary in the corpus. The value of the attribute is the English word at that position. To reduce the number of probabilities that needs to be estimated from the document, besides the naive Bayes assumptions of independent of the different feature values given the class label, we are going also to assume that the probability of a given word, WK, occurrence is independent of its word position in the text. In other words, we are going to give up the position of the words and the order of the words in the document. So we'll have something like anything that's px1 equal wk, which means that wk is occurring in the first position in the document, given the class cj, and P of X2 equal WK, WK occurring in the second position in the document given the class CJ, etc. All these kinds of probabilities will be all estimated by only one probability estimation, which is probability of just the appearance of the word WK given the class CJ. So this will simplify. We're not going to calculate all this, every single possible probability. We're just going to stick with the probability of the appearance of the word in given the class CJ. A good estimate for text classification is as follows. So the probability of a word WK given the class CJ, we're going to take NK plus 1, where NK is the number of times the word WK occurs or is found among these NJ words positions. And NJ is the total number of words positions in all training examples of the class CJ. So we're going to correct for having this probability equal to 0 by adding 1 to the denominator and adding the size of the vocabulary in the numerator. So that's enough for actually estimating the probability and avoiding having the probability being 0 for some words that do not occur in one class or another one. So the following function, or algorithm that we will see next, will learn the probability P of WK given CJ, describing the probability that a randomly drawn words from a document with class CJ will be actually the English word WK. It also learns the class priors, which is just the priors in, for example, of spams and non-spams in the dataset. The first step is to collect all the words, punctuations, and tokens occurring in the examples. Let the pertinent vocabulary in this case be V. For example, V will not include all the articles, but just the most important words in the corpus that we have. We're going to, in the second step, to calculate the probability of each of the class and the probability of each of the word given each class. So it's going to be calculate P of CJ and calculate P of WK given CJ for each C in the class C, in the set of classes C. The set of doc J will be then the subset of documents from the set of examples for which the label is CJ. So I'm going to partition the set of examples into, let's say, the document that are for spam and the document that are for non-spam. So spam will have only the text or the emails that are spam. We're going to estimate the probability of CJ, which is the class CJ, as the number of documents for that class divided by the size of the documents. Text J will be actually a single document that will concatenate all the documents in the document J. So for example, if we have the set of emails for spam, we'll just put that together as a corpus for text for all the emails that are actually spams. NJ will be the total number of distinct words in text J. For each word in WK in the vocabulary, we are going to calculate the number of times the words appears in the text. We are going to estimate the probability of WK given CJ, which is the formula that we actually just saw, that is the M estimate specific for the text. And at the end, we are going to output all the probability of each of the class, these are the priors, and all the probability of each word in the class. So after estimating this probability, we can use them to estimate the label of a new document. Let this document be doc. The function classify naive Bayes text will return the estimated label of this document. It's going to, first of all, collect all the AJ, all the AI that denotes the word found in the ith position within document. So I'm going to collect all those words that are in the vocabulary. So first of all, step 1 is to collect the positions. So I'm going to go through all the text, collect all the words from the vocabulary. So we're going to collect those positions. We're going to return the class doc that is estimated based on CDoc equal to argmax of P of CJ times the product of P of AI CJ for all positions. So we're going to take all the words appearing in the document. We're going to do the product of all those words in these positions, and we get an estimation of the class CDoc.